For problem number 28, we have an arrow being shot into the air, and we're given an equation that represents the height of the arrow at a certain time, the time after the arrow was shot. So in other words, at time 0, if you plug in a 0 for t, you would see that h of 0, which is the height at time 0, before the arrow is shot, the arrow is 5, we'll call it feet. I'm looking at the book, it doesn't give us feet. So we'll say height in feet, and we'll just give it something here, we'll give it a unit of measure, and the time in seconds. So the height then at time 0 happens to be, if you plug in a 0 for all the values of t, you get 5. So in other words, if we look at a graph, we would see that if we just find this is the h of t axis, and here's the t axis. H is the height at a certain time. So the height of the arrow is 5 feet. So it makes sense, 5 feet high at time 0. And then we're supposed to answer a couple questions. But before we do that, let's go ahead and graph it. And zoom standard is where we normally start, but we're not going to be able to see much of the graph, as you can see here, because zoom standard goes from -10 to 10 in both directions, but arrows usually fly higher than 10 feet. So let's go into our window and adjust that. The x, remember here on our calculator, the x represents time, so time can't be less than 0, and then we don't need that. 10, it looked like on our graph originally that 10 was plenty of time in the air, so the arrow will fall before 10 seconds. And then the y min, the y is the height, so the height can't be lower than 0. But what I am going to do is I'm going to start the height at -5, because then I'll show you what that means here in a minute. But it'll be easier to see the x-intercepts if we allow the y min to be -5. And then the y max, I don't know how high it's going to fly, but let's say 100 feet. And then go to xres 3 and hit graph. So that was a good estimate for the height. 100 feet high is at the top of our screen, and then we can see our x-intercepts, which we'll get to. So that's the graph, and let's go ahead and draw the graph on here. We can easily find the key characteristics of this graph. The keys would be here at the vertex and then the x-intercept. So let's try to figure out what those mean. This is really, really important that you understand what these mean. We know how to find a maximum. Second, calculate maximum. We can scroll down and hit enter, or we can just type a 4. Anyway, it's going to ask us for a left bound. We move the cursor to the left of the high point, mark it with enter, and then move the cursor to the right of the high point and mark it with an enter. And then it's asking us for a guess. Move the cursor anywhere in between those two lines and hit enter. So we can see that the vertex is at 2.25 comma 86. There we go. So 2.25 comma 86. That means, you should know what that means. When the x value is 2.25, meaning at 2.25 seconds, the arrow is 86 feet in the air. And that's the highest that arrow can fly, 86 feet in the air. So at the 2.25 second mark, the arrow is at its maximum height. And then we want to find our x-intercept here, and we go second calculate 0. So an x-intercept is the same as a 0. It's the same as letting y equal 0. So we hit 0, and again we're asked for a left bound. We move the cursor to the left of. So left of meaning horizontally. It looks above, but it's still left of the x-intercept, and we mark it with an enter. And then we move the cursor somewhere to the right of that x-intercept, and we can see as we move to the right, we use the right arrow, and then we hit enter. Even though we can't see the cursor, it still registers as being on the graph. Now we can see that the two vertical lines surround the x-intercept, and then it's asking us for a guess. We're going to move the cursor back to the near where the x-intercept is, and we hit enter, and then enter shows us exactly, and we're going to round to the nearest 3 digits after the decimal, 4.568. 4.568, 4.568, comma 0. And that's an important feature of the graph because that tells us that at that time the height was 0. So what does that mean? At that time the height was 0. Arrow goes up in the air, goes 86 feet in the air, and it comes down, and at the 4.568 second mark, if the height is 0, that means that the arrow hit the ground. The arrow is shot from 5 feet in the air, and then it's eventually going to hit the ground. That's what it means. That's the ground. This right here is the ground. So at 4.568 seconds, the arrow hit the ground. Hit the ground. Also, it was in the air. The arrow was in the air. So there's other ways to, in the air, other ways to ask the same question for 4.568 seconds. It had a maximum height of 86 feet, and on and on. So there's a lot of stuff that you can ask based on that one equation and based on the graph. But the keys here are started 5 feet high, flew 86 feet in the air, it took 2.25 seconds to get to that max height, and then it's got also the x-intercept, shows us how long the arrow is in the air.